This conference will now be recorded.
Here we go.
And we are. Welcome everybody that can join us right now. We're going to go through another Grasshopper working session, myself and Anish Reddy. We've had a few of these in the past that sort of lead up and build up to this point here. And I was describing a little bit earlier offline that we're going to do this one a little bit differently, where I'm going to just kind of open up one of these template files that has been built, try to just get oriented, reverse engineer it a little bit, work through the Grasshopper script with you all and describe it and sort of how it's working, and then manipulate a few things and start to play around with it. And eventually I hope that you'll feel comfortable doing that yourself with some of the tools, and in the future making them your own and adding your own information graphics or spin on the data, or your own building geometries or something like you see on the screen. So if you were to open the Rhino base file, which Anish has sent a link to, you should see this sort of geometry pop up. And I'm just going to go into the layer structure to describe what's going on there. So the HUD boundaries, that sort of came up in our last working session, where we had all this sort of really cool geometric but data-driven display objects. You don't see it on screen right now because I actually don't have the Grasshopper script open. But I'm just going to turn that on. And we said it was just like a series of boxes, right? And all this stuff is going to pop up on my right side of the screen. All this stuff is going to pop up on the left. And when I activate the HUD, I'll get this really cool heads-up display. But I really need those, but I don't need to see them. So I'll turn them off and I'll lock them. Zoom out again. And I just have three what I'm calling blocks. So this working session is about using maybe the HUD heads-up display toolkit to understand master plans a little bit better and to calculate data across a vast area or acreage of land, something we do quite often. So this was built with a few specific designers in mind and a project in mind. So we were sort of tasked that a way to look at this and see what it could do. 3 blocks, again, with different types of program. And these are just extruded volumes, again, just drawing a line or making extrusions from curves or surfaces, right? And then stacking them. They're all individually sort of parsed out because I want to be able to sculpt freely or design freely as I go and not being bound to any join geometry. The coloration and the typology of the program comes directly from our EM graphics group standard color palette for program typology. So the colors are sort of standard, and you'll see the pie charts and things that come up in the peripheral heads-up display to also share those same colors. So this sort of coordination across teams within the office for clarity and continuity. Again, I can just sort of turn on block 1 or 2 or 3. I also have a red lot line in here. Think of that as the property or acreage line, and some text labels just for myself, just to keep myself organized. All right. So if I was going to type Grasshopper, right, like that's going to bring up your Grasshopper interface. I've already done that. So here it is. It's nice and blank. All right. If I was going to go to File, Open Document, I could search for that file, but I actually have it open. So I'm just going to say, okay, I opened it. Yay. And here I'm in a massive file, right? It's not that big. A lot of it is repetitious. So I'm just going to minimize real quick, and now you see without doing anything, I just opened 2 files, and you're going to see all the work that we put into this script. So on the left, it is sampling block 1, 2, or 3, and it's giving you a breakdown in thousands of square feet for the areas associated with each one of these masses. So this is sort of a, splitting up 1, 2, and 3. If I wanted to go for more total counts and things, I could see my total area in millions of square feet is around 2.8. You can see my FAR, which is based, along the lot square footage versus the volumes, is about 6. And here my total areas is if these 3 pie charts got combined into one, and I can start to see how much retail I have versus parking. And then something pretty special and specific, which is where I see there being like a lot of flexibility in something like this. And he's just going to show you how to make a really sweet parking generator, and it kind of conforms to shapes. And this is a preview of what it can output very, very quickly just by understanding something like a rectangle. But I took the data from maybe what retail, office, and residential, you can put coefficients on volumes or square footages, right, to understand a parking count. So I'm saying, okay, let me analyze the entire master plan, see based on these assumptions of parking counts, and they can change whenever I want, what the need might be based on all the buildings I'm designing. What do I have provided in underground parking based on a ratio, but also based on Anisha's amazing addition to the script. And then what's the delta there? And if I start to extrude maybe some of the garage levels deeper into the earth or higher out of the ground, can I make an equilibrium in parking without ever doing a calculation in Excel or on my calculator? It's all happening behind the scenes. So maybe it's a parking count, maybe it's a bike count, maybe it's something completely different that I'm not thinking of, something you're asked all the time to calculate, and you really just want to have those values on hand as you design freely. Please stop me at any time if you have any questions. Again, I'm going to try to go a little bit just through this script and fumble around just as if I haven't seen it in months, because honestly, I haven't. I didn't write anything for this course, and I didn't really do my homework on purpose. So all the way to the right, this is a bunch of nodes all being merged into one. I know I'm not like showing you exactly what it looks like, because this is something we had done previously. It's where all the heads-up display stuff gets filtered in and displayed. Over here in these white boxes are some of where the pie charts happen, and the bar charts and things, which we did in, I think, the previous session. So if you need a refresher on any of that, that stuff's there. And you can also copy and paste it right into your own script. And some of these other little white boxes are the styles of whether, you know, the inside or outside diameter of this radius, the height constraint or limit in the Z on something like a bar chart. You know, what are we measuring to? Down to even sizes and shapes and fonts and color. All the new stuff is over here. But, and then down here, where we're going to get into Anisha's, we're going to step inside Anisha's brain, which is always an amazing place to visit. Here in the white boxes and everything up in this zone is what we're going to describe as block 1. This is block 2, and block 3 is just below it. So it's a copy paste. Again, once you build one, you can copy and paste it below, sort of track your wires, as they're called, through to the next visual display in the HUD, or the heads-up display, and merge it all into your output. So if I was to circle everything sort of right here, it's either things we've already gone over or things that you're going to copy and paste just this chunk up top. So let's go to just that chunk, and we can look at exactly what's sort of happening here and some other small calculations happening off to the side. So if I zoom in, I have some messy, apparently, directions. But one of them says right-click the node below and set a geometry for the volume. We've already done that. Office massing 1, if I were to right-click on it and say set multiple geometries, for example, I'd be able to select everything that's on block 1 office layer. And I want to say, okay, everything I'm drawing on that layer has a color. I want to set it. I also want to set a floor-to-floor height. Floor height right now is set to 15. I can easily change that by sliding it or typing in a number. Maybe I just want to change it to 12 right now, just for fun. I can choose a color. Office massing 2, maybe there's a separate massing that has a different floor-to-floor height, for example. So I'll keep this one at 15. Right? So you can make as many different office massings as you want. And the same ideology or logic goes to making other types of programs. You say, Tom, you don't have workout space, you don't have green space, you don't have things that I usually look at in my design process. We can add them, and we can add them, and we can calculate them any which way you like. Retail, we just have one simple one, 18-foot floor-to-floor in pink, and so on and so forth through the residential massing, which I'm keeping all at 18 feet floor-to-floor. And that's sort of it. And then there's a garage portion. This little preview here, if I click on it, again, like what happens on screen, right? Like if you want to reverse engineer something, you can either click on it and see a preview of it. And I say, oh, okay, all these wires are coming in here and I'm previewing something in white. Oh, look, it's all of the contour lines or cuts vertically through the building at those specific floor-to-floor heights that now I'm able to visualize and say, you know, I don't really like white. I want to make them like black. So now they're black, right? And I can just accept that change. So I can play with graphics and things pretty easily just by figuring out what stuff is. When things are sort of shaded out, you can right click them and turn the preview back on. It's just sort of hiding the preview output from you. But again, if I click on it now, after the preview is back on, I can see that it's sampling or sourcing this geometry, which is parking garage P1. So if I ever want to know what any of this stuff is controlling, especially the floor to floor, I can play with it, and now you can see that change pretty live on screen. Put it back to an easy 10. So let's work our way through just one of these strings, and we're going to go horizontally. Let's do something in the middle ground. Let's start with office. Again, that's at the top. All right. So we know that there's office 1 and 2. I can see that 2 is the bottom mass. It's cut at 15 feet floor to floor versus the 12, right? To an easy 12, double clicking, typing, entering. And what do we do with that information? Well, first and foremost, I want to find the closest point to 0, 0, 0 or origin. And the reason for that is all these models are sort of built next to the origin. So in order to contour them properly, I find the closest point. So the closest point, if I turn the preview on, for this mass here, which is stacked above the other mass, is this point. The origin is somewhere down here. Right? So it's the closest point, meaning what can I do from there? I want to contour the building vertically at the dimension specified, which is currently 12. Turn that preview off. That's just the logic behind where to start the contour. So even if I have a building floating up way up in space, it doesn't just start the contour wherever, it starts it right at that point that's closest to the origin. So I get an even number of steps vertically through the building. Okay. Now you have all the contours. Turn those on to preview. Awesome, there they are. I have 4 floor levels. I have drawn this at a specific height, probably to the other dimension, but that's easily changeable. I'll show you that momentarily. And what can we do with the contour outlines? They're closed rectangles because of the shape of my volume. And it looks like I'm going to try to get the area of them. An area is a wonderful tabulation, a data metric that we always use, right? So why not get some area? We're going to use a mass addition, just taking all the areas in a list, which are 4, based on those 4 contours. And then when I mass add them, I get 100,000.8. And that value is also happening in this bottom string, the exact same logic, and it's calculating this mass. Right? So mass number 2, different floor to floor. Let's find that point. There it is. Was there, different shape, makes sense. Awesome. We're contouring. Am I contouring? I sure am. Wonderful. Let's go through. What are the areas? Let's add them all together. And here's my data output. Okay. Now I have area from Office 1, area from Office 2. These are what's called a panel, right? So if you're going to double click in space and type panel, great way to triple check your work. I add them in many scripts just so, again, I can see the output, make sure it's making sense, or I can double check my math. Here's the mass addition to just add both of those together. And it's going through a rounding process here to truncate some of the values because I don't need so many decimal points when they show up on screen. Custom rounding, again, to truncate, and then that information gets plugged right into the pie as data. And that data, as it goes through the rest of the HUD system, gets spit out up here. So the one thing I didn't do, which I want to do, is what's the result? So I'll type a panel. What's the result of all that info? 241197. And if I look up here, 241.2. That's pretty small probably for your screen, but that is the number. So there it is, that purple pie B1. And everything adds up to whatever I've established as the massing group here. Great. Do it again for Office, do it again for Resi or Garage, what have you, and you will get a tabulation of a total area, and then you can even add them across another mass addition. You know, we're adding B1 office, B2 office, B3 office, and then all of a sudden you get this pinwheel, right, or pie chart. So just thinking about what type of geometry do I have? What do I want to get out of it to tell a story or inform my decision-making process in design using data? And how do I think linearly or logically about scripting to get myself there? And one easy way to do that is make a mass, cut it up into floor plates, and then extract area information. And from areas, you can do so much, right? All this stuff on screen is just based off of what you can do at a glance with area. Add it up, divide it by a factor to get an architectural value that we all understand for density, for example, or very specific about parking. So how does that all work? So there's a mass addition here that's taking into account all of the garage. And I can see that if I want to follow all these green lines, I know it because I built it, but it'd be a little bit hard to figure out that's what's happening. And maybe it's a good idea to add some notes, right? Like in your panels, if I was going to type a panel, here's a cool little trick that if I right click the panel, I can name the panel anything I want. And then there it is there. Again, if I right click, it's just right up here. It's not even anything to select. So I say, pretty cool. So I can say, oh, that's the parking spaces needed for office. Obviously, I'm doing something with the parking count. It's a good way to reverse engineer and say, what am I doing? Seems like I'm taking the entire area. I am dividing it by a factor to simplify that number. Seems like I'm multiplying it by a factor to extrapolate. And these are all sort of fake numbers. They can be anything you want to extrapolate a parking space need. So if you say, okay, I have X number of thousands of square feet of office or residential or what have you, can you come up with a number, right? That makes sense for figuring out what the need might be. So let me see if I missed anything. I think that's sort of it. Right? Cool. Does anybody have any questions regarding any of the organization of the file or why it's doing what it's doing? Would you like me to go over anything in more detail or build something custom? Custom might be challenging, but what do you all think?
I don't want to challenge too much. Custom might help me just because, like, starting from scratch a little bit, or at least like from a point where, yeah, because I definitely I'm a little confused still. Like, it makes sense, like like with the massing and connection and stuff, but it helps me if I like have something to go off of, like just at the beginning a little bit.
Yeah, let me do a quick mass to contour from the base point, for example. And you can sort of watch me work in Grasshopper, which I've heard from a lot of people is pretty helpful. So the terminology, I'm going to use BREP. Anish loves geometry. That's fine. I'm going to take that BREP, and I know I want to contour it.
Mm.
So maybe I just want to take this volume, and I'll right click and say set one BREP. And now you can see it's highlighted green. That's my preview. Click. Contour, if you hover, say, oh, that's not the right contour. That's the right contour. Yes. So this is a contour of BREPs or meshes. So if I hover, it says, what does S want? It wants an input of BREP, for example, and I will give it that. And then this little yellow bubble is saying, I need more. Input parameter D failed to collect data. Well, what is D? D is, if I hover, the distance between the contours. So I'm in a feet file. I'm going to type number slider.
Right.
And I'm going to say the number slider is in integers from, let's say, 1 to 40. And that would be 1 to 40 feet. And I can slide that and change that anytime I like. I'm going to choose 12. Double clicking inside of that or on it will get you all the parameters. It's very double click, right click heavy. And let's now give it a value D. So you can see there it is. Slicing it up any which way I like. From the contours, we're going to take the area command, and I'm just double clicking again, typing area. And let's say what does it want? Of course, it wants geometry. I'm going to give it these contours, which are, if I hover, it's going to tell me there are 7 of them. So I cut it 7 times vertically. And the area from there, I will say, is a mass addition. And to mass, add all of that stuff together. And I'm going to use a panel as a result.
So it does matter the order that you have, like those in like contour and area, or does that not really matter?
The order that this goes linearly matters very much, because there's not much you can do with maybe the volumetric area of a B-rep, unless you want volume, for example, but there are other ways to go about volume. So it's all about mathematics. Maybe I want to know the volume of that geometry, and I can tell you what it is in feet cubed, 1.404 to the 6th. Couple weird things that didn't happen here, like area, for example. It's giving me all this huge list. I don't want that. So there's a hidden thing where you come into A and you flatten it. Maybe something you don't know right off the bat, but that's already built into the script. And if you just kind of leave it as is or copy and paste, you'll get that inherent sort of hidden trick. And now as it goes through, it's all combined into one number. If I zoom in, oh man, my contour didn't start where I wanted it to. And that's because this doesn't fall on a perfect 16-foot value from origin. And that's why I say, well, what's the closest point? B-rep. Point.
Knowing the commands definitely helps. Man, I didn't know that's.
Oh yeah.
that's a very specific. I didn't know that was a command. B-rep closest.
Very specific commands, but so is sweep 2. So is.
Oh yeah, but I meant like B-rep closest. We never used that ever.
Okay. Sample point would be from the B-rep or not. Sorry. I'm just going to use quotation 000, which is origin, and that's going to give me a panel that says 000. And so that point is the closest point, and on contour, it says, where do I start? Where should I start? Right now it's saying start at the origin. And I'm saying don't start at the origin. Please start at this point. So if you look real close as I connect point to point, now that contour is right there, right at that point, which is exactly where I want it. So it's a little bit cumbersome, potentially. But at the same time, once you get there, I don't have to do much of anything. And to just show that off for just a second, and then I'm going to hand it over to Anish to say, I don't even need Grasshopper. I don't need Grasshopper anymore. All I need is what I have on screen, and I am a free, funky designer, and I want to break the budget. And I want to do all sorts of amazing things that they won't let me do. I'm just kidding. That's just me being a goof. Okay, and as I'm doing this, I'm sculpting by using Control and Shift. I'm selecting edges, I'm direct selecting faces, and I'm using what's called the gumball to push and pull, and you're seeing the values change constantly, down to a point where if I'm going to try to find 1,200 more parking spaces, I can take this garage and I can just bury it into the ground, and I should be able to, oh, that one's not connected. I have a flaw. There we go. I guess I was just calculating B1. But now I have way too much parking, like 9,000 spaces too much. Just by doing those small moves. I'm gonna go backwards to where I was. We're about halfway through the hour, and
Yeah, I'm sorry.
one-on-one, off to Anish to talk about his parking generator.
Yeah, I think that's a good transition actually to talk about that contours, right? So like Tom just showed how do you get that set of contours, and so I'm basically going to take one of those set of contours. That's the B3's parking contours. It's got nice little 4 levels of parking, and I want to basically draw parking on top of that. So I basically took that piece up here, and I used, there's a fun little thing called a relay, actually not array, but you can basically plug things into these things called arrays and move it around, and it's kind of like a pass through. It's like an easy way to keep track of things from one side of a script to another. But down here, basically, I'm using that to sort of get these polylines, bring them over here to this side of it. So I've got 3 sliders, the width of parking, the depth of parking, and the drive aisle. And so basically I want to find, parking layout it's pretty simple. Like the reason I did this is because even when you draw it with CAD or you draw it by hand, it's always the same process. It's the same sketch type process, at least for me, is, I'm gonna take the outside perimeter, line it with parking, find the inside, and then find an inside core that works for just rows and rows and rows of parking, and what was the most efficient way to do it. And then you start putting your vertical penetration on top of that. And so that's a way to plan out a parking garage, and I'm gonna sort of run through it. But it's an analogy to planning anything, right? It could be the office, how you do your office layout, or your residential layout or something, how you lay out rooms. But in this situation, I'm using it for parking. So let's say we've got our outside edges, and we want to explode these outside edges. And so now if we use a panel and look at what do we have $4 branches, 5 branches, because we have 5 levels, and we got a lot of, what was it, 6 branches, 6 levels with all 4 sides in each branch, right? And we can even simplify that if we just use the simplify command to make it just a 0, 1, 2, 3 for the names of those branches. I just like keeping it kind of organized, because then we can always come back and say, level 1, level 2, level 3. And then to get the inside edge, you basically want to you just want to offset that outside edge. So we're going to get a negative, we're going to use a negative 18, and then offset the outside geometry, these outside edges, by negative amount. So now in the same way, we've still got these same, I'm going to simplify them. Well, let's explode these two. Explode these guys. So now they're all, it's polyline, but now we can make them individual curves, right? So it's the same thing. The outside edges, and the inside edges. And they're all organized in the same way, right? Just a 0, 1, 2, 3, 4 stacking branch for each layer. So, we've got our outside and inside edges. But now we want to draw parking on these outside edges. So basically to do that, we want to get these inside edges and find the length of each one of these lines, right? And then we want to divide the length of that. You can see it's, if we use a panel to see kind of numbers we got, what am I working? I'm working in feet, right? So you've got, 304. It's always the same because it's just the same rectangle going up. But we're going to divide those by the width of our parking, which is 9 feet. And then you want to round it. You can only have an actual number, right? The number is going to be You know, panel is going to be something like 0.778, right? But you can't get 0.778 parking. So really, let's round it. And if you see here, we get the smallest one. Or actually, we want the largest one, or nearest. Why was I using nearest? It should be, let's divide the curve, basically. We're going to take these, this inside here, divide it with, I think it should be the smallest because we want to make the most, yeah, it should be big. So it should be that. So we're going to divide it by that. And so now we have all our parking spacing, right? These points are all saying the point on the other one. So now we need a point on the opposite edge. That's the closest point to each one of those points. So curve closest point. And then we're going to put these points in there. Looking at it. So now, so if we look at the division here, right? It's now our branches that were 0, 1, 2, 3, 4, they're a little bit more complex. Each floor has, like, what is this, 34 points in each one of them, right? There's this, let me do it in a wireframe, maybe you can see. There's stacks of these points, right? So now our branches have become a little bit more complex. Each line is now its own branch with all the points. So we need to take this outside edge and so the outside edge, if we look at how it's organized right now, it's 0, 1, 2, 3, 4. Right now, the lines aren't in their own branch. Here, each line is in their own branch. So we need to change, we need to take each one of these items and give it its own branch. So this is kind of some advanced Grasshopper stuff here, but it's called the path mapper. And I mean, really at the most basic level, it's doing, is remapping, right? We're saying this tree, which has branches A and items I, should now be reorganized so that, oh, actually we need to use a little flower brackets on this guy. It loves using the little flower brackets for the A because that's your tree branch. And then I is an item with parentheses, right? But now we're going to reorganize it so that it's actually a two-tiered list, which is A, but then also each I becomes an individual branch, right? So if I plug that into this, and then we get another one here, each one of those lines is now in its own thing, right? And you can see it's going to line up with these points. So that now when I say curve closest point for each one of these points, and you put these curves in, you're going to get, just to make it a little easier to see, we'll take the geometry in, the outside points, the corresponding points for these internal points, right? So that now all I have to do to draw my parking line is line 2 point, right? Because a 2 point line is the most basic thing. Let's start from the inside, A and then B. Now I've got all our parking lines. Let's go back to this so you can see it with, so in this preview, you can turn off all your previews, you can make a wireframe, or you can show it as shaded, and you can mess with all the colors and stuff, but you know, we can keep it simple. Oh, this is only draw preview geometry selected too. There's some fun little filters there. But let me turn off the preview for the other stuff. We can just start looking at what do we have here now, right? So now we have the outside parking layout. So that's fun. And how do we count this, right? If we wanted to count this edge parking, you basically want to find the length of this list, right? What do we have here first? Let's go back to this and look. You know, we have those lists, each parking line. So each row, the number, if you count the number of lines and you subtract 1, that's the number of parking spaces you have, right? Just on the basic logic of your row. So for each one of these branches, if I get the length of each one of these branches, it's 18, right? But now I want to subtraction 1, oops, 1 from each one of these. So it could be nice 17, 17, 17, right? And so now if I do mass addition, you have your total number of parking for, oh, we got to flatten it, right? You want to flatten it in one nice big list, and then you'll get one big number. So 13,260 parking spots on the edge. But if you wanted this to be, let's say, by floor, right? 0, 1, 2, 3, 4. So this is where it depends on how you want to do your parking counts, and understanding the tree branch really helps with this, because then you can start to make this, you can manipulate your data the way it needs to be. So basically you need to use Path Mapper in reverse, right? So now we have I, but instead I just want it to just be A, you know, just collapse all these guys together for each one. So it's going to be this. So then now if we look what we're getting, it's 0, 1, 2, 3, 4. And for each floor, we have all your parking numbers. So it's like 129 parking spaces for that. So now if I do mass addition for that, I'm going to get the number for each floor, right? 2,210. So you can do, what's kind of nice about that is, you know, I'm going to throw something in here, right? We've got these geometry points. Let's get some endpoints from this, right? We have these edges. Let's get this in, right? And then just to, right, we just want to get some points for each floor. It's like these corner points back here, right? Let's just say we want to get these corner points. So you can actually take these floor by floor points, because they're also organized the same way, right? It's going to be 0, 1, 2, 3, 4, 5. This is why that tree branch management is important, is you can do a text tag, right? A 3D text tag maybe, or a text tag in your Rhino viewport. So your location is going to be your points, and your text will be your mass addition numbers. And now you've got your floor by floor numbers right there, live on your model, right? So things like that. It just depends on your project, what you're doing, how you want to count your numbers, but just thinking about it in that way, that you can be creative with the way you want to break it out. But it's all just tree branch, tree management, understanding how that works. Yeah, so now let's go back to the interior. How do you get that interior drive aisle? So let's see. So we need to get our interior edges here, right? So right now, let's go back. Where was our interior edge? Was this guy, right? So that's this. And now we need to offset this again 24 feet for our interior drive aisle, define the interior box, and start laying out rows and rows of parking. So we're just gonna go over here and offset curve, right? And we're gonna take that same curve and we're gonna offset it negative with our drive aisle, 24. There we go, right? And so this gets a little weirder, because so when I also lay it out, you try to basically just figure out, it's kind of just how I would lay out a parking garage, that if you find the side that divides the best into rows in the most efficient way, that will press right up against your drive aisle, not leave a bunch of wasted space. So you kind of just pick, right? You might want to, you can either do like something like mathematical, but for the simplicity of this little like lesson here, I was just going to do a list item, and we're just going to pick, right? We're going to pick the defining edge. Let's use a number slider. From 0 to 3, because we have nice little rectangles, right? So that, got these lines, and we need to explode them. Explode it, simplify. And so now it's basically just saying, you know, which line do we want, right? Which one are we going to emanate out from? And then beyond that, what line is it going to emanate along is really going to have to be one of the adjacent ones, right? So we're going to do an addition, add 1 to this value here, and then put that into there, right? So if we look at both of these, we're basically going to always, as we slide, we'll get the adjacent guy, right? We'll have our starter that we're going to make rows and then emanate along this, basically with our parking and the drive aisles. So let's see, how did I do this? Okay, so we've got this, we've got the one we're going to make rows with, right? So let's make some rows first. Let's see, actually. Sorry, I'm kind of making this up as we go. Let's see. So first, let's find the length of all these guys, right? Let's see which ones are the right size for all this. So $228. So basically, what was this? Parking. Okay. All right, I'm just going to I have the script open here, and you might just have to see what happens as it goes, but I'm gonna discover too, because I haven't looked at this in a while. So multiplication.
Divided by 60, look for the smallest remainder between the two choices. Would that be?
Yeah, basically, right? You want one that has a small remainder, but really I'm going to set it up where it's just going to make it, and then if you'll look at it and be like, which one is better, right? Because we can just use the slider to pick a different row maker, right? So as long as you set up the process to just say, make your rows, a double-sided row and then the single-sided row. I mean, maybe if I save this, maybe I'll just save this as and just jump to the end. Let me do something real quick here. So I can open the original. So this is the fully complete guy, and so it's basically we just have to draw the first set of parking, right, which is going to be these guys, and then you just sort of put it across, right? You know that you're going to get a certain number of these double loaded things based on your horizontal. You array it, and then you count them all the same way you counted it before. And so, I mean, it could break down whichever way you want. Like you're saying, you could do something to say, what is your better remainder? What's the smaller remainder? And then use the number with the smaller remainder. Or you could just use a slider to switch between it. But it's basically, you just draw that first set, array it the number of times that you can fit, and then, see how it works. So I go back to this, I can even change the one, right? Let's change it to that way. But if you see it goes that way, it's not as efficient, right? We have that big gap. So let's actually do the other one, right? So it's just about picking the right side and finding the side that you're comfortable with. And generally with these scripts, you're not going to get exactly perfect. Obviously there's some leftover, but it's just about ballparking it and trying to see just at a geometric level, like what is probably a good number, and then cross-referencing it with your square foot number too, right? Because certain shapes, it also helps you reveal that certain shapes, because for the most part, this is what you want out of a parking garage, is a nice, clean 90-degree thing. So it starts to reveal that certain shapes, maybe something more rectangular or something, like certain gauges of size are not optimal for parking garages, and you want to have certain large numbers to get you over that hump. So yeah. So, I mean, it's kind of an analogy for anything. This could be, lining up rooms along a corridor and like that. But I did this for parking because I was doing a lot of parking layouts in a project. So, and I think a lot of people do it nowadays too, right? So, yeah.
Great.
Super cool.
Any questions? Somebody
If
put
you
something.
did like an arc-shaped building, I assume it would still work.
Oh, if it was curved? No, this is for the rectangular. But I mean, curved parking, a curved parking garage is pretty bad, right? Like, or if it is curved, you have to think about how you break down your parking in a completely different way, right? It's going to have something different. And so whatever that way is, it's almost like the way you sketch, the way you construct a drawing, you go through those same steps in Grasshopper. And I did this way because it works for a rectangular parking garage, but yeah, a circular one, you would do circles and radii and stuff like that to find your numbers. So that would just be a different way of doing your math, and every project is different. But I think, it's just, that's why we want all the designers to really know this stuff, because there is not going to be a one size fits all, right? It has to be, how are you designing? What is your system, and adapting the system for that. So to really understand it, you really have to understand at that basic level, and understanding like, okay, what is the math of my parking garage, and how am I going to do this differently?
Right, and they may actually pick a number that's friendly to parking to draw their initial outlines. If experience, so that would make it
maybe 45-degree parking, right? Angled parking throws this whole thing in a different route anyway, because then your drive aisles are different, then it's one way, and then yeah.
That's right. Go ahead.
No, I was just saying that really works out well, and especially being able to pick the 4 different sides and see them in real time, how they lay out. That really is useful for the designer to see those different alternatives. So I think I agree with you that it's better than just doing a test and having it all internally. So that's neat.
Yeah, I think some folks have had some success using tools like this, and especially the stuff that that cool text object and you put on the corner of the building to see visually on screen, and not just in a pie chart or what have you. You can get more granulated information. Now, people have made design options in front of managers, principals in our office, and I think they love the immediate feedback of a design change. And Anish, if he was going to make another level of parking, he could tell you how many parking spaces are on that level. He could tell you what the overall count is for a master plan, and he can tell you if you're over and under in less than 5 seconds. And that is just, I mean, for me, that it just makes me happy in like the nerdiest way.
Where is this mask? There we go. I'm just gonna mess with it. Let's see, what do I control shift one of these?
You have the volume open?
How do I have to just box out it? Can I just box out of it?
You can box out of it. Yeah, go ahead, go nuts. It'll get weird. You should be able to direct select the bottom face. Yeah, there you go. Something like that. Cool. Scale it. Yeah. I mean, that's pure sculpting at its finest, I mean, yeah. So cool. Like, kind of clay.
Oh, is it constraining it? Oh,
is it
if I do move face and then direction constraint none, I can get buck wild with this. There we go. Ooh, some angled parking. It works. Kinda.
Hologram work.
I guess it's slanted because it's a rhombus, but then if I pick a different side, it'll be better. Maybe you want it to work that way though. I don't know. It just depends. Yeah. So yeah.
Need something to read the angle and then sort of multiply the width by something.
Yeah, I
Yeah.
mean, it's also that an angle kind of isn't great for these like drive aisles because you are going to have these big open. I mean, this is kind of, yeah, it's kind of, yeah,
It'll change the numbers if it's angry.
yeah. It just depends on the width. It needs to be like the perfect width to get that third aisle in there and still have 24. Yep. So yeah, that's that.
That's fun.
Groovy stuff.
All right.
Yeah, thanks
Well,
for
real
everybody.
quick. Yeah.
We'll see you again soon. If anybody has any feedback, comments, compliments, anything, we'll take it. And any ideas or specifics on future working sessions, something you're interested in. I know Komet had a question about maybe building from scratch and starting again from the basics. And I am happy to do another basics 101 where all we do is look at simple terminology and nodes and start to really understand the canvas that is Grasshopper platform.
But you guys did
Okay.
a great job sort of making that the big scary looking diagram less intimidating. I have to say, you know, you really did help me anyway understand how those pieces come together, and you know, it's not as scary as it looks. So thank you very much.
All right. Well, until next time, we'll miss you guys, and we'll see you again soon.
Thank you. Thank you so much.